Welcome back to Arts Learning. In this video, I'll be going over the Triboelectric series and how to solve problems regarding it and what it means, what it's conceptually, as well as what implications it has on different materials. Okay, so first, Triboelectric series concerns a lot of objects. Okay, as you can see here, quite a few objects that are charged by friction. So, for example, remember, okay, that's a bad drawing there. You remember if you take your hair, right? If you take a balloon and you rub it on your hair starts to stand up, right? And the balloon, when you put the balloon near your hair stands up even more. It's attracted to the balloon. Have you ever wondered why that happens? It's because of the triboelectric series, okay? And what the triboelectric series says is that when you rub two materials together, right, it transfers electrons. So you generate friction between those materials, and then you transfer electrons. Okay? So imagine when you rub the balloon near your hair, right? The balloon, right, made of rubber or plastic, takes your electrons. So it takes the electrons in your hair, it takes extra electrons. So think of it like it has 2 protons, 2 electrons, right? So usually in chemistry, each element has the same number of protons as electrons, okay? But once it gains more electrons, the protons can't match these electrons, right? Then now there's more electrons, so it becomes negatively charged. Negative charge. So then, if it takes electrons from your hair, imagine your hair has the same scenario, right? Positive, positive, negative, negative, everything cancels out. But if it takes electrons from your hair, what are you left with? Only protons. So then your hair becomes positively charged if you have more protons than electrons, and the balloon becomes negatively charged. And you remember what happens when two materials of different charges come together? They attract. That's why your hair stands up. It's trying to reach the electrons it lost. Okay? It's a very interesting phenomenon. And we'll go over what these rankings are here. So these rankings go from most high to most low, okay? And it measures the probability of an object to gain or lose electrons. So glass is the most likely to lose electrons, okay? It's the most likely to give away electrons. Teflon is the most likely to gain electrons. So in the scenario where I rub my hair on the balloon, right? The balloon is made of plastic, or sorry, actually rubber, probably. Rubber, right? And my hair is my hair here. So my hair is on the positive end, which means it's more likely to lose electrons. And my rubber is on the negative end, which means it's more likely to gain electrons. So rubber will takes electrons, right, from my hair. And that's what this series is about. Okay? So it doesn't need to be all the way down on the bottom, right? If I rub my hair and wool together, so even though my wool is not in this section here, since the wool is lower than the hair on the triboelectric series, the lower it is, the more probable it is to gain electrons, okay? So the wool takes electrons from the hair. Wool takes electrons from hair, okay? Same thing with glass and hair. Even though these are the most positively probable items, if you rub your hair on glass, your hair will take electrons from your glass. Okay, so whichever object is below, right? So if you're given two objects, whichever object is below is gains the electrons, right? So whichever object is below the other one gains the electrons, and whichever object is above loses those electrons. Okay, that's all you really need to know. After that, it's really not that hard at all. So let's see, glass rubbed with silk. So I mean, you're gonna need the table, so let me scroll up here to the table. Where is glass and where is silk? So glass is up here at the top of the triboelectric series. Silk is over here. The one below gains the electrons, the one above loses the electrons. So the silk takes electrons from the glass. Right? So then that means glass loses electrons, right? So glass becomes positively charged. And since silk gains extra electrons, it becomes negatively charged. And then accordingly, they're going to attract each other. Okay? Let's try some practice problems. You rub a rubber rod with wool. Rubber is lower on the series. Which object becomes negative and which positive? So that means rubber gains electrons, right? Lower, always remember, gains. Above, gives. Lower gains, above gives. So rubber takes electrons. Or in this case, actually, wait, what am I saying? Rubber is lower, so it gains electrons. Yeah, it takes electrons. And so when an object becomes negative and which object becomes positive. So if the rubber, if you imagine, same thing, right? Balanced charges. If it gains electrons, the rubber becomes negatively charged. Negative charge. And since the wool loses electrons, since it loses electrons, if it loses these two electrons here, it becomes positively charged. Okay, positively charged. All right, so now let's look at the second one. A glass rubbed with silk rod is brought near a second identical glass rubbed with silk rod. Okay, so there's a lot of things going on here. And we're asked whether they attract or repel. So first off, glass, right? Glass is rubbed on silk. So if you look at actually we have it right here, right? Glass becomes positive. So this glass gains a positive charge because it's most likely to lose electrons. And I just showed you over here, right? And then if it's brought near another glass rubbed with silk rod, which is also positively charged, they're going to repel. So triboelectric is not always about attracting, okay? Sometimes in these scenarios, they could also define repelling. So they repel. Okay. Compare the force between 2 microcoulombs and negative 2 microcoulombs at 0.1 meters versus the same pair at 0.2 meters. What pulls harder and by what factor? So here, when we take a look at this, so you might be like, okay, well, what's the relation here, right? So the relation here is that, so let me actually show you here. Since the force is directly or inversely related to 1 over r squared, right? If both of these 2 microcoulomb and the negative 2 microcoulomb at 0.1 versus the same pair at 0.2. So since 0.1 is lesser than 0.2, if you look at what it says here, right? KQ1 and Q2 over r squared. Since 0.1 is lesser than 0.2, the force is going to be greater, right? The lesser the distance is, the better. The greater the distance is, the more trouble that occurs. So this one pulls harder, more force. And by what factor? So KQ1, Q2 over 0.1 squared, which is 0.01, okay? And then KQ1, Q2 over 0.2 squared, which is 0.04. So 0.04 over 0.01. This one pulls harder by a factor of 4. And I'll show you why that matters in a sec. Okay. A neutral metal sphere, okay, a neutral metal sphere is brought near a positively charged rod without touching it. Why is the sphere attracted? So think of it, right? A neutral metal sphere is brought near a positively charged rod without touching it. So this is a positively charged rod. Why is the sphere attracted? So what happens here is, if I was to draw the composition of this ball, a lot of positives, a lot of negatives just floating around, right? Some of them are attracted to each other, whatnot. So what happens here? It shouldn't be attracted, right? It has neutral charge. But what happens is the positives are repelled by this positive, okay? They're repelled by these positives here. They're repelled, they're pushed away. The positives are pushed away. So I can't even see which are these. So this is an electron, another proton, one electron. So the positives are pushed away because these are repelling, makes sense. But what happens to the electrons? They're pulled towards. So once your transformation is done, your composition is going to look more like this. Electrons are going to be closer because they are pulled that way while the protons are repelled, right? And now you can see why, since the electrons are closer. So the positives do repel, right? But what happens when the positives repel? That's a greater distance because they've been pushed away. So this distance is greater than this distance, right? Distance 2. So these will have a larger force and accordingly, they will pull harder. That's why I was showing you what this meant here, right? The distance gives you the stronger force. So these positives do repel, but the thing is the force is overcome by the electrons, the power of the electrons. All right, and there you go. That's all for Triboelectric series. So this is a tough concept. Make sure you understand well what's happening there. I was also not that happy with it when I was first acquainted with it because it didn't make much sense. But now you can hopefully understand it better. Make sure to give me a like and subscribe so you can stay updated on all the tools you need for your physics journey. After this, we'll go over one review for the PDF that I have, and then we'll move on to Unit 7, which covers circuits. Thank you for watching.